This is a very good shot because it shows more than what I wanted it to. It gives you a perfect chance to not only show that first we use the brass washer inside. This is hard to do because it's backwards from what I'm used to. We have the brass washer inside under the screw head, and you can see where the lead wire from the transformer assembly is soldered directly to the screw head. Of course, you don't want to do that while it's in the pipe, it'll melt. But the thing that I like about this shot is it shows the notch where I cut with the hacksaw, and that notch is only the width of a blade, but it's just enough flexibility in there to where a hose clamp will tighten it up after an adjustment and lock the adjustment, and yet when the clamp is loosened, loosened to the point to where it's still snug and doesn't move around very easily, but just loosened up a little bit, it'll permit free adjustment of the loop's tilt angle, and the one at the bottom of the T will permit adjustment and lockdown of the loops, it'll permit lockdown and alternately adjustment of the loop's bearing angle. So it's a simple technique. You use the saw to cut a notch across the opening, and that gives just enough flexibility. Like I said, it'll let the pipes turn while you're making the adjustments, and then tighten the clamps up, and it'll lock it right down, keep the wind from blowing it out of adjustment. As long as the direction of your hum fields in your yard stays relatively constant, your loop is going to maintain whatever null you set it to. So that's the easy way to make it adjustable, and yet make it reliably lockable down, or down lockable, or anyway, it'll let you lock it down after you adjust it. Okay, on the top side, each terminal is built from first a brass washer, and then a brass nut, another brass washer, and then a brass, or in this case these are nickel plated, but anyway, a knurled nut. I'm in the United States, so we're using American hardware. It's 832 by 1 inch screws and 832 washers, 3 on each terminal. Well, this is another fact worth mentioning. I didn't make a lot of detailed explanation on how to choose a container for the transformer assembly, but the one thing that I should have said at first is it's vitally important to make sure that there's enough clearance between the container you choose and the inside wall of your pipe for the wiring to go past the container. As I said before, the container is from a vial of test strips that goes with a glucometer. I'm a diabetic, so I have to use test strips every day, and I have these containers. Any small pill bottle or any other small plastic container that gives a sufficient amount of clearance between the inside of the support pipe and the wiring. At this point, we're not assembled far enough to show, but the 14 gauge wires from the loop will have to pass right next to the container. In fact, we'll turn it around and try to I have to insert it into here. Okay, what will happen is this is a pretty good representation of the way the wires will sit in a fully assembled unit. Zoom in on it a little bit, bring it a little closer. Okay, the assembled unit. Okay, the secondary wires, they go straight to the terminals. They'll be just like you see them here. The primary, what I'll have is the 14 gauge wires from the loop will come down around here somewhere, and the wire nuts will come up. This wire will also come down and then back up. Will form drip loops. When I assemble my loop, I doubt if it'll be watertight. I do expect some rain to get into it. Therefore, of course, I'll have the container for the transformer assembly, have drip loops inside, and that's about it. When you choose a container to build your transformer assembly, just be real sure to leave enough clearance. Make sure you use a container that has clearance between it and the walls of the support pipe. This is just a piece of pipe about 6 inches long, and what I'll end up doing with it is use it as a stand, because the entire unit will stand on just a short section of pipe like that. The T will be adjustable, so it'll allow the unit to stand very much like a kickstand on a motorcycle. Now on to the pipe assembly part. As I've said before, this entire unit is made of Schedule 40 PVC pipe, and the elbows and T-fitting are the supply type. Be sure to use the supply type because they have straight edges and they go together smoothly. Now this is going to involve some panning around with the camera. I may not get real good angles. Unfortunately, my lens is not wide angle enough to show the entire loop. The parts are laid out, and that's one of the main reasons I'm doing this part. Is these parts, as they're laid out, have already been pre-glued, and I have them pre-glued, and I'll show the rest of the preparation. This loop will be fully assembled, and then the wire will be wound inside of it, and that's one of the big reasons why I chose a 3-turn design and why I use a step-up transformer. In theory, at least, a 33-turn design without a transformer would work fine, but I wouldn't want to have to wind it. I'd have to take a long pause in the recording and delete a lot of expletives if I did 33 turns. One of the main reasons is for each turn we wind through here, we'll have to pull all the wire through all the pipe. And in my case, since I'm using, well, the top pipe, it's 36 inches, and it has a coupler. I didn't have a pickup truck to drive home in, so I drove home in a car, and I bought my pipes in 2-foot sections, so that's why I ended up with a coupler and a splice in the top pipe. You can use a 36-inch pipe, that's fine. And okay, now, like I said before, or did I say before? I don't know. Anyway, these pipes are laid out to show the overall shape of the loop. These pipes, anywhere where a fitting is connected to a pipe, has already been glued. I pre-assembled it, saves time, and I've worked up a good assembly plan, so we'll go through it. So first we have one elbow, then the 36-inch pipe, the second elbow on the top on that 36-inch pipe, and I might as well also advise, in order to keep confusion to a minimum, I took a Sharpie marker and I marked the length and the description of where each piece of pipe goes. Top pipe, right elbow is already glued to it. Side pipe is the right side, of course. It's been marked, showing 24-inch. Side pipe right. And then the bottom elbow is glued on. We'll turn it around and show where I have cut from this direction down to about the middle, and from that direction down to the middle. This serves two purposes. This will be an access port for winding the loop, and it can also be used as a rain drain. And I still have the pieces. I'll leave my pieces out and use it as a drain. But if you wish, you can take your PVC pipe cement and glue the piece back in. It won't fit exactly because the width of the saw blade will be removed, but it can be used that way, or you can use JB weld to build up the difference and actually put it on smoothly, and then before the epoxy cures you can smooth it out and make a pretty good cover. Since I only have two and they'll be on the bottom, I'm not going to cover mine. I'll let the rain drain out of it. Next, we'll do the left bottom pipe. Left bottom pipe, I won't give you a measurement on it. The reason I don't is because it's made like this. That's kind of sideways. See if I can get the camera in.